So when we are taking measurements in chemistry, we are going to be encountering different numbers. And with these different numbers, we're going to have zeros in these numbers. So what we need to talk about is when do we need to pay attention to zeros and when can we completely ignore them. So if I have a measurement of 53.0, or if I have a measurement of 4020 or 0.00310, when do I need to worry about those zeros? When do I count them as significant? Meaning they gave us some information from the instrument itself. So again, we started with this idea of taking a measurement one beyond what the instrument is giving us. So we have a guess. So this is an easy way to determine when zeros are important and when they're not. This is my method of teaching it. Plenty of chemistry teachers use this. But if you talk to other teachers, they might do it a completely different way. So what it's going to be called is something called the Atlantic-Pacific rule. And the reason we use this is it kind of simplifies like 5 or 7 rules that you sometimes see books refer to. So I want you to think of the United States of America and think of the fact that we have the Pacific Ocean on the left and the Atlantic Ocean on the right. So what we're going to use is the P in Pacific to be when the decimal point is present, and then A for the Atlantic is when the decimal point is absent, meaning there is no decimal point in the number. So we have 2 sets of rules called the Atlantic-Pacific rule. So if the decimal point is present, so you see these 2 numbers here that have a decimal, we always are going to read from the Pacific side, and I will go through an example here. And every number starting with the first non-zero digit is significant. So again, if it is a digit 1 through 9, it is always going to be considered significant. The only thing we need to worry about is zeros, okay? Whether or not zeros are important. So if I take 0.0350, okay, since we have a decimal point present, what we do is we start counting on the left-hand side, the Pacific side, and we don't start counting any digits until I hit the first non-zero number. So that means I don't count this first 0, okay, because I don't have a non-zero number quite yet. So I start counting at the 3. So that means 3, 5, and 0 are all significant in this measurement. So that means I have 3 significant figures or 3 significant digits. They are interchangeable in the world of chemistry. Likewise, if I have 245.0, again, the decimal point is there. Yes, there is a 0 after it, but since the decimal point is present, we start on the left-hand side. So we count the 2, the 4, the 5, and the 0. We keep counting until we are done, okay? So that means this is 4 significant figures. Also think, mathematically, do you need to put that 0 in your calculator? You don't, okay? You could just type in 245 and do whatever calculation you need to do. So obviously I wrote this 0 down for a reason. There must be a reason behind why I wrote it down. So it must mean it is significant, okay? So that's the Pacific rule. So if I have the Atlantic side, and I apologize for the zooming in and zooming out, if I have no decimal point present. So that means, again, it doesn't, and we know there's a decimal point, everybody. But if it's not written in the number, so 2500 or 65057, there is no need for a decimal point for those numbers. We are going to read from what we call the Atlantic side, and every number starting with the first non-zero digit is significant. So that means instead of starting on the left like we did here, we're going to start on the right. So we're going to do 2500. Okay, so we're going to start on the Atlantic side, so the right-hand side. We are not going to start counting until we hit our first non-zero number. So this 0 is not significant, this 0 is not significant. Now it's important because it tells you the size of the measurement, okay, but those 2 don't count. So the only 2 that count are the 2 and the 5. So I have what we call 2 significant digits in this number. If I take 65057, Again, there is no decimal point present, so I'm going to start on the right-hand side, the Atlantic side, right-hand side. I'm going to start counting when I hit the first non-zero number. Well, that's the 7s. That means the 7, the 5, the 0, the 5, and the 6 all count or all significant. So again, we've covered all of the rules that they talk about in the book, like if a 0 is between, if the 0 is on the end, it doesn't count. If a 0 is starting the number, it doesn't count either. If it's after a decimal, like at the end of this number, it does count. I just like the Atlantic Pacific rule because it kind of boils it down to two things, meaning you start on the left of the number, you start on the right of the number. That's why I like it. Again, if you look up Atlantic Pacific, you might find somebody who can describe it even better than me. Okay, so going back to these numbers, pause the video and see if you can figure out how many significant figures you have in each measurement. So pause the video and see if you could use the Atlantic Pacific rule. So decimal point present, Pacific side. I start on the left. First non-zero number until I'm done. So 53.0 is 3 significant digits. 3 significant figures. Same verbiage. I know it's 2 different words, but it means the same thing. 4020. This has no decimal point present, so I start on the Atlantic side. I do not start counting until I hit the first non-zero number, so I do not count that 0, but I do count the 0 that's between. So that means that is 3 significant figures. And finally, 0.00310. I start on the Pacific side because I have a decimal point present. So I do not count these zeros. That just tells me how small the number is. So then I go and see that I have 3 significant figures or 3 significant digits in this measurement.